Okay, so today's lesson is for Tuesday, October 25th, 2011. We'll begin today's lesson by talking about how to use a compass. You'll notice that at each lab table there is a compass. You're going to want to be referring to that compass as we go through directions on how to use it. We're also going to be, after we learn how to use that compass, we're going to apply that knowledge to actually go outside and conduct a lab where we take some vector measurements. You remember that vectors are measurements where you're given a direction and a magnitude. So we're going to need to use this compass to give us the direction of our measurements, and then we'll be using a meter stick to get the actual magnitude. So if you actually to click on this information on reading a compass, it would take you to this web page. And this web page does a pretty good job of explaining the usage of the compass. It's really important that you know the 4 cardinal points. You have north, south, east, and west, right? And those are the cardinal points. You have intercardinal points, and those would be northwest, northeast, southeast, and southwest. You can break them up further into these gray lines, which are the secondary intercardinal points. We're not going to talk too much about those, but we generally use these points to give someone a general direction of where something is. You could say that a person is northeast of where you are, and that would tell the person that they were in this direction to the northeast of you. All right, so that's a basic way of giving someone directions to a location or a place. But if we wanted to be more specific, we would actually use a compass. On a compass, you'll notice that the compass in front of you has a dial, and that dial is broken up into 360 degrees for the number of degrees in a circle. The other thing that you'll notice on the compass is that it has an arrow, and for us, the arrow on our compass, if I was to draw this out more to represent how big your compass is at your table, it would have an arrow up here. Now this arrow is the arrow that we use to orient or show our bearing, where we want to go to. So we would point this arrow at whatever location we wanted to get to. The other thing that you'll notice on the compass is here it's marked by a red dot, but for us we have 2 green little markers on our little dial here. Now those markers are going to be really important because we're always going to want to turn this dial so that the green markers line up with the red needle that points north. And we'll talk about an example and how that all works. So we know that we have a needle here. It's broken up into a north for the red and a south for either the black or white, depending on what kind of compass you have. You'll also have this green marker, and you'll have this arrow at the top of your compass that we're going to refer to. So let's talk about how we would use a compass to find the direction of something. So let's say that you're standing somewhere and you want to know where your friend was. Let's say that your friend was right here. Because the needle's pointing here, it makes it easy. So we point the needle at your friend. You're standing over here where the compass is. And the red needle is pointing to the right. You would orient your dial, you would turn it so that the little, on here they have it as a red shed, but we're going to want to go ahead and show it as green because yours is green. We'll orient this red needle so that the green part is holding it right in the middle. And then from there we just count the number of degrees till we get to the arrow. So we would just count the degrees going around until you got to this arrow. Okay, so I want you to pick something in the room, pick an object, and try to do this. I'm going to walk around and we'll talk about the usage of your compass and make sure that we're all on the same page with how to use the compass. Alright, so now that everybody knows how to use a compass, we're going to go ahead and look at what our activity is for today. We're going to be going out to the teacher's parking lot. And you'll know that when we walk out here, we generally walk in from this direction over here. And our goal for today's lab is to add vectors graphically. So we're going to be taking some measurements using a meter stick and a compass. We're going to be starting on this end of the parking lot, so we're going to have to walk all the way across. It's going to be really important that you don't walk near any cars, so I prefer that you guys walk down the middle here and then towards the back, just to make sure we don't get any complaints from teachers or faculty about you guys riding on their cars or anything like that. So we're going to be working on this little section back here because it's generally empty, no cars parked back here. I don't want to see anybody over here in this area where there are cars. Now, when we get back there, we're going to have to pick a starting point. So let's say that your group gets back here and they choose to make this their starting point. From there, that person, whoever's at the starting point, will keep the compass, and they'll have another person come out to another location, it should be at least 5 meters away. I don't want anyone picking a point like right next to them just so they don't have to walk. I want the minimum distance to be at least 5 meters on each of these points. Now from here you'll get your compass and you'll point the arrow to the location you want to go to. So we'll point it at the person that's standing away from us. And then you'll locate the north on the little dial, just like we talked about. You'll align your little green marker by turning the dial so that it's right in between the green part on your compass. And then we'll actually just measure the number of degrees around and write it down. So this would be, if this was north, that would be about west, right? So about 270 degrees west. So our first vector here would be 270 degrees west. And then I would actually write out the magnitude or the amount. So we'd use our meter stick and flip it end over end and get the distance. So let's say I said the minimum distance is 5 meters, so we'll use 5 meters here. Okay, so this is a vector. It tells me the direction and it tells me the amount, the magnitude. Okay, so that's my first vector right here. From this point, the person with the compass will walk up to where this person was, and this person will go to a new point over here. You can go to any point you want. You can go backwards, around, as long as you stay within this area that I talked about. So when you go to the new point, the person with the compass will do the same thing. They'll go ahead and point the arrow on the compass towards the to where the person is at now, and you'll go ahead and realign the marker with the north on your needle, and you'll get the degrees, and you'll write down your second vector. Okay, you're going to do this 7 times. You need to get 7 vectors before you come back in today. All right, now when you finish, you're going to end up at some finishing point. Now, after doing all this and you end up there, we can actually calculate your displacement, which is the magnitude or amount that you are from your original location. So you'll actually measure that distance and you'll get that direction also. So at the very end, you'll measure your distance back to where you started, and you'll get your direction not from where you finished, but from where you started. So you'll have the person with the compass stand where they started and get the direction down to where you finished. All right, so we're going to get the 7 vectors, and our last value is going to be our displacement. But this should also have a directional component. Again, you start from the start to where you finished, and then a magnitude, a value for how much. We're going to do that outside, and then we're going to come back inside, and you're going to fill out this procedure section with the exact procedure for how we did the lab. So put it in your own words and do your best to make sure that someone could repeat our lab exactly the way that you did it. And then down here, make sure that you put all the vector values here. I don't want to see them all written up at the top by the map. I should see them here nice and neat, vector 1, vector 2, vector 3, and then where it says calculate your displacement, you'll write out your displacement right there. When we come back in tomorrow, we're going to be discussing how we would take those vectors and actually graph them onto this graph paper. We'll write out our conclusions, and you'll be able to turn this lab in tomorrow. Also, if you have a binder, we'll do the binder checks when we get back into class after we've been outside doing the lab. Sorry about that. That concludes the lab, and it's going to be really important for safety reasons that when we're out there, you stay away from cars. I don't want to see anybody leaning on cars. If you see any cars coming, obviously get out of the way. We don't want anyone to get hit. It's going to be important also that when you're out there that you respect their property. I don't want to, like I said, I don't want to see anybody leaning on cars or anything like that. And that concludes the lab for today.